So, last along this line is insulated concrete form. Now, this diagram of course, we will come to later on. Insulated concrete form or insulated, it is the ICF as we call it, is a system of formwork for reinforced concrete usually made with rigid thermal insulation. So, the formwork is made of thermal insulation, right, and that stays in place as a permanent interior and exterior substrate for walls and roofs. That means, here is the other way around. Earlier I had two leaves and then the core was insulation. Here the formwork itself is formed by insulating material and it remains there, it does not go away, it is a part of the system itself. So, you are actually saving on to your formwork cost, because formwork itself is going into the construction itself, right. So, stays in place something like this, but supported by steel frame, metal frames or such system. So, first you have insulations on this side and this side which are supported, the metal frame should be removed, but the insulation remains and concrete is inside. These forms are interlocking modular units, the forms are interlocking modular units that are dry stacked without mortar, stack them up and filled with concrete. So, for example, if you have polystyrene, expanded polystyrene, right, expanded polystyrene here and then fill in with concrete material here and this remains. Obviously, they will need some finishing on top of them, you will need some finishing on top of them. So, they form actually interlocking units, because one panel and another panel they have to be interlocked. So, that are dry stacked and filled with concrete, the units locked together somewhat like Lego bricks or create a form for the structural walls or floor of a building. So, ICF construction of course, is a commonplace for low rise and commercial buildings and high performance residential construction as well, because you can design the system accordingly. If you are looking for high energy efficiency, then this kind of systems are must, right. Also for natural disaster resistance buildings. So, this is how it looks like, So, you can see the formwork, the reinforcement inside, right, and then concrete will be poured into it, then the whole system goes away, this is of course in situ, straight away in situ. So, it remains there straight away. So, the wall is created by sandwiching concrete between each of these layers, designed to provide stronger, more comfortable, quiet and highly energy efficient structure. So, that is what it is. So, here are as you can see here, the first level of the wall is being constructed straight away here, this is in situ, right. So, it looks something like this, ICF wall looks like this is your concrete, this is a dry wall and they are separated out, stacked, and some finish you will have to have on top, some plastic webbing of course you will have to do, and steel rebars are also inside. So, essentially it is other way around. Earlier one was a core being insulation, here the form itself is insulation and that remains. So, easy to construct and their lifespan is many years longer compared to regular construction methods, that is all right. So, the web provides support structure for each side of the form and for reinforcing material. So, this ones they provide actually support structure for both the types of forms and reinforcement, supporting the reinforcement, they remain there, they will remain there, they will also remain there, right, and that is what it is. So, insulated, they are manufactured from any of this material. For example, you can have polystyrene foams, as I said, expanded polystyrene thermocols like things, or polyurethane foam, right, So, like Soy-based foam, cement bonded wood fiber, so you can make wood fiber as well, cement bonded polystyrene beads, cellular concrete. So, all other kind of insulating material can go into forming these foams. Reinforcing steel bars are usually placed inside the forms before concrete is poured to give the concrete flexural strength. Like other concrete formwork, the forms are filled with concrete in 30 centimeter or 1 centimeter high lifts as normal casting to manage the concrete pressure and reduce risk of blowout. That is one thing, because the form is not as strong as normal steel form, let us say. Steel normal formwork that we use in cast in situ quite often is 3.5 mm what we call a BP sheet, particular steel, but this is used deliberately thinner ones because you do not want it to be heavy, and you will have normally you will have angles at the 600 by something like 600 by 400 panels. They will be bolted, if you remember, somewhere you might have studied, you will have angles at the end, right, and there will be, of course, this will be bolted here, angles for connecting the next panel. So, they are in panel forms of steel, they are panel forms of steel usually, and two of them will be connected like nuts and bolts. So, simply we will connect them, tighten them up so that the concrete does not ooze out. So, that is the conventional formwork. Now, this is 3.15 millimeter thick, the conventionally used in India, or you can have even smaller ones perhaps, but this has been conventionally used. Now, pressure on the formwork is something of this kind. Pressure on the formwork is something of this kind. It is not exactly hydrostatic pressure that like this, So, fresh concrete does not offer hydrostatic pressure as such. Why? Because the time you pour, it sets, some amount of setting would occur. So, the bottom concrete, it can withstand on its own. So, you do not get a full pressure at the bottom. It is, not exactly this, something like this it would be. So, there is somewhere in between you will have the maximum pressure, right. So, wet concrete density into GH, that would be the rho GH would be the pressure. Pressure is something of this kind. Now, to depend upon therefore the height. Now, here your form is not as strong as the steel plate. So, your lift thickness has to be conveniently thought of, considering both the web this web connectors and the insulating form that is there. So, it has to be designed accordingly, right. So, can be 30 centimeter to 1 meter high lifts to manage concrete pressure and reduce risk of any blowout. And then of course, concrete can cure in situ, no problem. Thermal insulation obviously, but it is something different. It is in a slightly different manner, because now you have the insulation is on the periphery, right. As an insulation it will perform equally good, because as you know 1 by U is equals to simply 1 by HO plus sigma Li over Ki plus 1 by Hi. So, sequence does not matter here, this side or that side or core, it really does not matter, because it is L by K. So, whether this side or that side, it will not matter, but it matters in terms of decrement and time lag, right. It would matter in terms of decrement and time lag. Why? Because if I have a high storage material at the outside, first it will store and then allow the heat to go, right. So, storage obviously in this kind of material, storage will be relatively less, but they are insulating. So, the amount of heat coming in, which is Q is equals to U A delta T, as you know. So, if I look at the thickness through which it will pass, K, L over K, etc., etc., if you look at it, so it will not allow much heat to pass through, but storage will be less. So, accordingly time lag would depend upon the mass of the concrete, that is structural concrete which is inside, but U value is going to it is going to be high because it is insulating itself. So, that is how it looks like. So, this is how so you have got this plastic ties. Plastic ties are important rather than steel. The reason is, if you put in steel, acoustic insulation will reduce. Acoustic insulation would reduce, because steel transmits sound, right? Steel transmits sound, and if those who have done a course on building energy, acoustics, etc., you would remember that tau bar, what is transmittivity of sound, average transmittivity of sound, is a function of A1 tau 1 plus A2 tau 2. So, if the transmittivity of one of the function is very high, then insulation quality, and insulation quality is given by 10 log 1 by tau, right. So, this steel plate, if you are steel connected, then that is not a very good thing from acoustic insulation point of view, even from heat transfer also, but then the area is small. So, would not affect so much, but transmittivity it quite reduces significantly, one can show by simple calculation. So, therefore, preferably you put in plastic connectors, right, plastic ties, and therefore, grooves can be there, right, and this is the concrete. So, some sort of strips, polystyrene is here and some sort of strips, and you can give kind of look as you want. So, this typically something looks like this. So, it is also a multifunctional system, it is also a multifunctional system, both thermal, designed for thermal acoustics as well as load bearing system themselves, right. They do improve indoor air quality, regulated humidity levels and mitigated algae or mold growth, can act like a high grip buffer, water, wall block panels, lintel system, etc., can also be made. Regulated humidity level and mold growth, if you have humidity level is maintained, then obviously you will not have mold growth, such things. High thermal insulation, that is what I said, and good thermal mass if you desire, because mass will come from the core, the concrete part of it, thermal mass will come from the concrete. So, structural RCC and strength as required. Now, fire resistance, the insulation material normally are not good fire resistant. Thermocol will simply, in fact they will add to the fire load, right. They are carbonaceous material, they will add to the fire load, they are good insulation. So, you have something, the finish itself has to be fire resistance kind of finish, that would be there on top. Sound, as I said, sound absorption and low transmission, and you can make ductile, because core concrete and its reinforcement will make it ductile for seismic resistance. Initial cost is slightly higher than conventional, and one thing you are reducing is the formwork cost, right. It is a part of the system itself. So, formwork cost you are reducing, life cycle cost is much lower. So, that is what it is, and technologically advanced production is required. You cannot make it, cast in situ construction is usually semi engineered or non engineered, that cannot be done. You have to do it skilled workforce who know about it. So, these are the kind of systems which go, which can make sustainable concrete, which can make sustainable construction system. And then let us look into one or two more of the system as similar systems which are there. We will look into this. One of them of course is a modular, one of them is a modular concrete construction. But just before that, there is this sort of formwork, I think some of you might be familiar with this. This has been used in India for quite some time. we call it tunnel form. I think I have not discussed this. I will just discuss this and then discussed it a little bit. Yes, last class I must have mentioned something about this, but this has been used in India since 1990s. I mean at least used somewhere, and this is a 3-dimensional system. So, let us look at them. Now, tunnel form construction process, structural strength, I think I must have mentioned this in the last class. Did I mention this? I think I did mention this. Tunnel, this one, structural tunnel is created. So, we create a structural tunnel, looks like this, as we shall see later on, simply looks like this. Formwork looks like this, right. So, you will have this is the inside of the form and another one, and it would be propped up. So, it looks like a tunnel like this. Excuse me, looks like a tunnel, something like this. So, this is the form, and this. So, it actually can form, it is a cut, it is a cut shown, cut. So, these are all on wheels. This is the bottom of the slab. This will form the wall, or let me see if I can show it better, something like this, maybe. No, this is the starting point, not really. I'll come back. Yeah, this is the part of the form. There will be a similar sort of one on the other side, and just let me see if I have a better diagram. Yeah, this is a better diagram. So, this is the formwork. This is the formwork. This is the other formwork. This is the wall, which is cast monolithically with the slab, and this is the other one already cast. Already it has been cast. You will have reinforcement placed here, cage is formed, complete cage, and do the concreting. That means this, and this is supported prop, etc., and this is a turnbuckle arrangement, each keeping the space. So, basically it is like a tunnel, and once you have finished, you can collapse it, roll it out a little bit, a crane can lift it and place it on the next one. So, speed of construction goes very high, speed of construction is very high. So, in this one speed of construction is very high, and a structural tunnel is created, right, by pouring concrete into steel formwork to make the floor and walls. So, basically you have floor and the walls, they are all monolithic, therefore, you can reduce down the material consumption, and since the whole system is shifted from one point to another point, not a panel and normal formwork, therefore, production process or construction process is pretty fast. So, each 24 hours the formwork is moved, so that another tunnel can be formed. So, you pull it out, put it in the next place. Now, the concrete has to then harden by that time. I mean it should finally set and should be able to take its own load. So, what is done is heat curing. So, you actually heat curing is done. So, you have a heater inside the tunnel, as I will show you later on. So, when a story has been completed, the process is repeated for next floor. So, strong monolithic structure thus constructed can reach 40 or more stories in height. So, therefore, you can actually make relatively taller building with this. This is what it looks like. So, if you look at it, there are horizontal panel. So, this is a horizontal panel, make the floor, bottom of the floor, right, bottom of the floor. Then vertical panels. So, vertical panels are this one, concrete will come on this side, concrete will come on top of this. Inclined struts. So, these are inclined struts which will support the form, and they are on wheels. So, you can separate down, make it a little bit collapse and pull it out, whole thing is together. Triangular support prop, there are triangular support props are there, wheels are there. So, it is on wheels, so they can move easily, they can move wheels, whole thing can move easily. Then there will be a jack, right, there is a jack which will which can actually do pressing, press and things like that. And back panel, this is the back panel, other side, slab suspended and wall stop. So, therefore, this is the slab for end of the slab, concrete has to finish. So, that is what it is. And box out, anyway 10 is box outside, if you have kind of a like kind of a insert into the wall itself, because concrete will come here, concrete will come here, concrete will come here. Thus, you can use high strength concrete to ensure fast construction. For example, if you make a 80 MPa concrete, then its 24-hour strength will be also proportionally high. So, you can shift it out. I mean, you can design the system accordingly, heat curing, make it high strength, so that you can remove the foam early. So, early striking at 15 MPa strength, if in 14 hours if you achieve, then you can simply remove this foam out, right. So, that is how it looks like, the same one photograph. So, here the concrete will come, right, and here the concrete will come, here the concrete will come. This is the portion which is supporting the slab part of it. Okay. So, the first step is to cast the slab, including the 75 mm starter walls at the bottom, the ground floor level, that are used to position the tunnel form, right. So, these are the ones, and then tunnel form is placed on top of it, tunnel form is placed on top of it. The starter walls must be carefully positioned and their vertical alignment must be accurate, then they come here on top of it. Rebar is embedded, right, starter walls 2 feet on center. So, that is what it is. Reinforcement comes on top of this is the ground floor level. After starter wall forms have been stripped, room length sheets of welded wire mesh is tied to the rebar. The rebar provides continuity of reinforcement for each floor level to the floor level below. So, from the bottom one, the rebars are connected to the top one, then placed by crane. So, this the crane can handle the whole thing. So, one crane lifts it up, puts it straight away between rows of reinforcement. So, it puts reinforcement has been erected, these are the lesser reinforcement cage. Now, tunnel form comes here, tunnel form can come here. Already constructed wall might be there, right, and tunnel form comes here, the crane just puts it there. So, and aligned and level with screw jacks and things like that. That is turnbuckle arrangement. A turnbuckle arrangement will have a like something like you have a rod, then you have a there will be inner threading in this one, and from this side you have there is one which will have a thread here. So, if and then handle you will have some handle, as you rotate it, it goes inside, and rotate it either clockwise or anti-clockwise to spread, cause this turnbuckle to spread. If those who may not have seen ever in the site, this is what is a turnbuckle will look like. This does not have this will show something like the spreader, actually they will spread, this is not here also. So, that basically that sort of spreading arrangement can be there and alignment can be maintained. Okay. If you have electrical conduit, you can always place them there. Installed in the box out, also you can have a box for doors, right. So, this whole thing is being lifted by a crane at the ground floor level. So, any openings you required, you can always have pre-cut, and wires reinforcement is pre-cut actually. For example, this is a fan, a heater and a fan. This is a turnbuckle I was talking about, this is a turnbuckle. So, you rotate this, you can see there is a rod sort of a thing, this is actually a handle. So, if you rotate this, either it will close or it will open, because there is a threaded portion inside here and there is a thread, inside thread and outside thread. There is a sleeve on which there is a thread and this is a rod on which there is a thread. So, you rotate it, and this is a fan which is blowing actually the heat, so that fast curing can occur. Just a minute, let me show you the door. Yeah. So, this is the window, one can have a cut for the window, right, and wires are cut accordingly. So, for either side are then placed, okay, etc. The right heating and fast curing, as I said, struts actually transfer the load of the concrete to the base of the tunnel forms, and this is how it is. It looks like. Did I miss anything out? Just a minute. Yeah, this I said. Electrical conduits can be installed, box outs, windows, etc. You can put in, and so on. Right. Okay. So, heating I have already mentioned to you, and this is how it is. So, this is what is cast already. Now, this will be cast, the tunnel form has come, this maintains the this actually carries the load, right, transfers the load to the from the slab to this and to the bottom, kind of a bracing, and then put in the reinforcement, the concrete comes in, and here is the concrete has now come in, wet concrete, it has come in here. The rods of course protrude out for the next level, and so on. So, here this is the already existing floor, and so on. Then there must be heating. So, heating in order to get it first cured, right, and the slab reinforcement then you put in, first is the wall reinforcement, then slab reinforcement, cast the slab is cast, and once this box is complete, then follow it up on the other side, and so on and so forth, and this is heat cured. So, first step would be to place the rod here, which is already existing, just tie it up maybe, or if it is already the sufficient length is there, that might be there. Then you put the tunnel here, cast this, put the reinforcement here, cast this portion, ready for heat cured, cause this to collapse a little bit, pull it out. So, it is a very fast construction and monolithic slab and wall construction. This side has to be filled in with some sort of infill material like AEC or something of that kind. So, they can combine. It is a fast construction actually, and sustainable in the sense that you can make high strength concrete, reduce down the materials and material cost, right. So, even something like this hotel buildings one can construct out of this, similar, of course, it has to have similar shape and size, and that is what it is. So, tunnel form are cleaned and oiled for then reuse. Time of construction is reduced labor and supervision cost, quality and design are the major advantages along with time saving of cost. Initial cost is higher. In all this, initial cost is a little bit higher, better planning and coordination. Initial cost can be 3 times than conventional form. So, somebody has done a case study in India, and this case study is very interesting. Procurement cost was 22,000 per square meter for this one. Conventional 800 per square meter. So, you can see 800 to 22,000, not 3 times is much higher, right. Casting system, monolithic, etc., RCC framed structure, and this is monolithic slab and etc. Floor, 1 to 3 days, this requires 3 to 4 weeks. So, the time is the factor. You can finish a particular floor in 1 to 3 days, and this is 3 to 4 weeks. And very skilled labor, speed of construction is very high, slow, non-skilled labor, obviously quality will be poor. Labor cost relatively less here, because they are skilled people, you will have to pay more. Staff required is not very high, but this will have high. Reusability, many a times you can use them, because it is a much sturdy system. So, it is more than 500 times plus, that is what is being said. This is 15 to 25 repetitions, and then you need the crane, you need here, you will not need anything, accuracy is very high, design flexibility is not much actually in terms of, because you have all shapes are dimensions are fixed, room sizes are fixed. So, very good for a hotel, very good for similar sort of construction where you can use them. Finishing, yes, good finishing. Safety, you have to see the crane, and construction safety is very important. Waste disposal, hardly any waste comes in, and scrap value of course is high, because that the formwork itself you can set. Net floor area to gross very high, because wall is thinner, right, and then earthquake resistance and etc., that would be high. Cost save 45% based on you can save, time saved, that is very high, and highly favorable where you are doing more than 15-story building and you want to do it in a very short time. So, that is what is the tunnel form. I think we will stop it here and we will look into concrete modular in the next class, and I will not go into this. So, this you can understand, it is a modular box, complete box, modular box, and you can build in lot many things in this one. So, it is a 3D modular system, and we will look into other some similar advanced industrialized construction in the next class.